Sections 4.4 and 4.5 are on logarithmic functions and models. In particular, these two sections are about the natural logarithm. So what I want to do first is go through and introduce you to what the heck that is. And we'll start off with a few definitions. So first of all is the number e. The number e is defined to be the limit, which we haven't talked about, but I will explain what I mean by this in a minute. The limit as n approaches infinity of 1 plus 1 over n to the n. And this ends up being approximately 2.71828, and so on. So a few things. First of all, we're defining e here. Okay, so what this limit means is that as n gets very large, one plus 1 over n raised to the nth power gets closer and closer to the number 2.718, and so on. So e is sort of a number like pi, so it's a transcendental number. So this means its digits go on forever without any sort of discernible pattern. And this number is super useful, just like pi is. So another definition. The natural exponential function is f of x equals e to the x. So we've looked at functions that look like f of x equals a to the x, right? Or exponential functions. So the natural exponential function just has base e. Okay, what else do I want to say here? I guess since we've been talking about logarithms, we should also define the natural logarithm. So the natural logarithm is the logarithm with base e. So that's log base e of x. You won't usually see it written like this, though. We'll usually write it as ln of x. What else should we say here? How are we going to use the natural logarithm? It's just like the usual logarithm, right? So if we take the natural log of e to the x, I get x. So ln undoes e to the x, just like log base a undoes a to the x. Yeah, okay, I think that's what I want to cover for now before we start the first two problems. So we need to complete the following statements. ln 556 is the power of what that gives what? So let's remember our formula, log, I want to use the same one that we've been using, so I have to look back in my notes to make sure I'm using the right letters. Maybe log base a of x is equal to y, if and only if a to the y is equal to x. So here, ln of 556 just means log base e of 556. So it's going to be the power of e that gives us 556. ln of blank is the power of blank that gives 0.71. Well, it'll be just like part A, it'll be the natural log of 0.71 is the power of e that gives us 0.71. And finally, if e to the y is equal to 12, then the natural log of blank is equal to y. So using our formula over to the right, we know this should be the natural log of 12. Okay, problem 2 says to evaluate the following without using a calculator. So remember, e to the natural log of x is equal to x, and the natural log of e to the x is equal to x. So for part A, we have e to the natural log of 17. So that means that this should just be 17. So for part B, which is the natural log of e cubed, if I write this as a logarithm like we're used to, the base is e, x is e cubed, so that y needs to be equal to 3. So the natural log of e cubed is equal to 3. So this is also using our exponent rules for logarithms. I took the 3 out front, so natural log, not of 3, of e to the 3 is equal to 3 times the natural log of e. The natural log of e is just e to the first, so the natural log of e is 1. So this is 3 times 1. Okay, and then 1 over the square root of e. So what I like to do for these, anytime I see a square root sign, is get rid of it. So write it as like a 1/2 power. So this is going to be equal to the natural log of 1 over e to the 1/2. And since e to the 1/2 is in the denominator, that's a very bad ln. Since e to the 1/2 is in the denominator, I can rewrite that as e to the negative 1/2. So I'm just left with negative 1/2.